Okie dokie. So, welcome to class, the two of you that are actually here. And welcome to class, everyone else who's going to watch this later from their bedroom. So, I actually got a webcam, so I can show everyone. Here's our book. Okay, see the book? Pretty book. We're actually going to start using this. Probably not today, maybe today, we'll see. And then definitely next class period, we're going to actually start into the class, thankfully. I'm sorry this has taken so long to get through all this, but there's a lot to learn. So let me just state a few things on Canvas here. Oh, we got someone else. Yay. Okay, so I have posted 2 assignments. The first one is a quiz on Linux. Okay, should be fairly simple. Set the quiz up. You have unlimited time to take the quiz, and you have 2 tries to take the quiz. So, and it does not tell you the answers afterwards. Sorry. And then the other one is our first actual programming assignment. Okay, and this is just a simple assignment. I want you to write a simple hello world program in the language of your choice and submit a TGZ file, which I will cover today, with the following. You need a source code, a makefile. That makefile needs to have 3 targets. And I'll explain a little bit more about that in a bit. Make note that you need to use the GNU compilers because that's what I will be using. And then a PDF file, which in it has your name, your A number, the date, a title, I don't really care. I want a plot of y equals x squared. Okay? And I want a paragraph on your hometown. Okay, this is the format that we'll be using for all the other projects. So I just wanted to get that out there and make sure everyone knew what was going on.
So format, what do you mean that's the format that we'll be using? Because, all it says is what needs to be included on there. It doesn't really say, like...
I'm not specifying a format, okay? Not in the paper ASME type of format
that's
way.
fine.
So yeah, this is, if you submit something, I will give you full points, okay? But I will be making sure we get through this process correctly. And I'm actually going to talk about this a little bit more later on and give everyone an example. Okay, so today we're going to be talking about how we actually program in Linux. Okay, so whether you're using your own personal computer or the resources that are available. Hang on, let me check something here. Oh, I can't change that. Oh well, I guess everyone gets to look at my ugly mug. Okay. So when you're programming in Windows, you're typically going to be using Visual Studio. Working on a Mac, I'm not really familiar with that. But Visual Studio, at least, is what they call an integrated development environment. They try to hide the normal complexities of compiling programs. Okay, on Linux, there is no such thing. Okay, Linux is based on the philosophy that we're not going to hide anything from you, so you can be amazing and have all the control you want and shoot yourself in the foot if you want. But in general, there are a few steps to writing a program. Okay, and we should be I'm assuming everyone's pretty familiar with these. So you write your source code, and then you compile each file into a binary file. On Linux, these typically have a .o extension. And then the next step is to link all the binary files and any necessary libraries, which are typically .a or .so files, into an executable file, which you can then run. So the first step, writing valid source code files. I've run into this problem before when helping people. People think source code files are somehow special. Okay, they're not special. They're just text. That's all they are. If you're using a specialized text editor that understands what you're trying to do, then you often can get, syntax highlighting, other cool things like code folding and stuff like that. And so it makes it easier to work with your code if you use one of those. So when you're writing code in Linux, there's Vim. I'm sorry for those who had to deal with my echoey recording of the CHPC. I did ask them in there if they had any GUI text editors available, and they said no. They said, we recommend you use Vim or Emacs. I personally use Vim. Okay, there is a GUI version called gvim. So there is that. If you're just looking for the basics on your own personal computer, does this draw? Oh, it does. Okay, so this is what's available on CHPC. On your own personal computer, you can use these ones here. These ones are pretty good. They're just very simple, very lightweight. There's not a lot of complexity to them, but they will highlight your code. Some of them do some code folding, stuff like that. And then these last four, these are actually full-fledged IDEs. They try and be like Visual Studio replacements. I personally find them too complicated for my taste, but a lot of people do like them. So you're welcome to take a look at that. Okay, so then we have to compile our source code. And what that means is a separate program called the compiler reads the source code and interprets it and translates it into machine instructions, which are the binary files. There are other programming languages which are called scripted languages. For these, a separate program, again, which is typically called the interpreter, reads the source code one line at a time and executes each instruction. Scripted languages tend to be slower than compiled languages because there is that waiting time. MATLAB is a scripted language. Python is a scripted language. Bash scripting is a scripted language. And we won't be using these. So, what does a compiler do? Okay, a compiler has an extremely difficult job. Okay, they have to produce correct binary instructions that are efficient, hopefully, which are correct. They have to do what you tell them. And that's probably the hardest part, is they have to be correct. And they have to work on a large variety of hardware. And that is also very difficult. And lucky for us, lots of people work hard to make this happen so we don't have to care about it. But a compiler typically runs through several steps. The first step when you're dealing with C is, and C++ is the preprocessor. Okay, that's all the include statements and all the define statements. If you see these things, include, define, those are all preprocessor statements. Fortran, if you're using modules in modern Fortran, it has to create .mod files, which actually is not that bad. I actually really like that because a .mod file is nothing more than a .h file for Fortran, but you don't have to write the .h file. The compiler does that for you, which is nice. Then if you're doing C++, then it has to run through the template preprocessor if you're using templates, and that can chew up a lot of time. From there, it creates what they call the syntax tree. It's kind of this abstract notion of of what your code is supposed to be doing. Then it has to do optimizations on that syntax tree. That's typically called a front-end optimization. Then it has to compile it to assembly, which is the intermediate language. And if you want to learn assembly, go ahead. I wouldn't recommend it. But assembly is how they used to, in the very beginning of computers, is how they made programs. Okay, it was in assembly. It's the last step before binary instructions, essentially. From there, there's more optimizations. Those are called the back-end optimizations. And then from there, they compile it to the actual binary machine instructions. And once you get all those, then you can link them together into an executable program. And you get a nice little file that you can run. And that contains all of the instructions to tell the CPU what it needs to do. So, compilers. First, we're going to talk about C and C++. The first one is the GCC, which stands for GNU, or GNU as they call it, compiler collection. And I think they have over a dozen different languages in this compiler collection. It's free, it's open source. I'm assuming it's kind of the most widely used compiler out there for those reasons. If you're compiling C, you're going to use the GCC. If you're using C++, you're going to use G++. This is the default Linux compiler suite. It typically works very well. There's hundreds of people working on it. Unfortunately, though, it tends to have rather cryptic error messages. And you spend a lot of time Googling, what the heck does that mean? Then there's CLang. It's based on GCC. This is a project that was started some years ago by Apple. It's free, it's open source. CLang and CLang++ has slightly more helpful error messages. And sometimes if I'm having problems, I will compile using this to try and figure out what's going on. The programs are typically not as optimized or efficient as GCC, but a lot of people like it. Okay, if you're working on Windows, there's Visual Studio. And everyone who uses Visual Studio swears by it. However, you cannot use Fortran, but most people don't care about that. I believe there are free academic versions, but it typically costs money, I believe. And then there's the Intel compilers. Intel loves to focus on performance, and they typically win compiler benchmarks. I mean, they hire people to sit there and twiddle and tweak every little thing to make this thing go as fast as possible. It costs money, although there is a free version for academics. It has a very strict license on what you can and can't do with it. And this is available on the CHPC's resources. And it's the one they recommend because it goes the fastest. So in Fortran, Fortran, of course, isn't used as widely. The compiler support is not quite as large. And so if you want to see what a compiler supports or doesn't support, sure. You can go to this link here. How do I make it go to the link? Control clicky. Nope. Okay, copy. Paste. So the Fortran 2003 status is mostly green. They have several compilers listed here. The ones you'll probably be mostly interested in is GNU and Intel. Okay, and this is all the cool things that are available in the 2003 standard and whether they are supported or not by that particular compiler. So that's helpful. There we go. Alrighty. Oh. Okay. So in GNU they have GFortran. This is based on the originally on the F77 compiler and the G95 compiler. Newer features may or may not be implemented, like I said, as it has a very slow development. G95, which some of you may have been told to use, is crappy. Don't use it, okay? Intel has typically the best. PGI and Cray are competitors to that. Intel is typically the best because Intel invented Fortran. So there you go. So Make. I want to talk about Make. Make is yet another programming language, and its goal is to compile large programs reliably and quickly. Okay? It's what they call a build system. Now, an IDE like Visual Studio has its own build system, and it manages your project for you. Since Unix and Linux has no, one IDE to rule them all. That's what I'm thinking of. We have Make instead. And there's lots of different build systems out there, but Make is the one you probably see the most. So I have linked here a short tutorial and a long tutorial. And I'm not an expert on Make. I've never really needed to be. But I do know enough to write small things that are helpful. And so I'm going to, we'll get back to that. Okay, I'm going to give a quick demonstration here of Make. Oops. Okay, so here's my hello world. Let me blow this up so everyone can see it. And we'll... Okay, can everyone see that? Okay, so the program Make, okay, so there's a separate program called Make. It is the interpreter in this case. What it's going to do, it's going to look for a file in your current directory called Makefile. You'll see I've got one listed up here. And so this Makefile is going to have what you call targets. Okay, so typically the very first target is what they call the all target. And so when you type make just by itself, it's going to open up the make file, and it's going to execute the very first target it sees. Okay, by custom, it's just called all. Now you'll see here I have variables, and I've specified these variables. It's very similar to a bash scripting variable syntax. And I think they did that on purpose. But you'll see I have here CXX. That's very typical for a C++, since plus is not, you can't use it in variable names, so they use an X instead. Think of it as a tilted plus. And I've said I want to use the G++ compiler. If there's any flags I want to give it, I put them here. I say I want you to compile these files. And then I'm going to call my executable hello world.exec. Okay. And so what it's going to do, it's going to take, if I take my variables and put them in this $ curly brace syntax here, what it's going to do is actually going to substitute those in. So this is literally the same thing as if I had written G++ and then -G-O0 hello world.cpp-o. Okay, so those two things are the same thing. But by putting them in variables, I can use them a little better. I can reuse them, in fact. So, also in a make file, you typically have a clean target. Okay, and this clean target, its only job is to remove the executable file. And then I have a third target in here called run, and it is going to run the executable file. So let me just demonstrate how this works. If we do make clean, you'll see it executes remove hello world.exec, and you'll see that it's now gone. If we just type make by itself, it runs the first target, which is called all, and it runs that execution. So now we have hello world.exec, and then if we do make run, we run that program, and it spits out hello world. And for those who are curious, this is what that looks like. So simple, spit out hello world. Alrighty. So that is what I want your projects to look like. Okay, I want you to have a make file and 3 targets. I want you to have an all target. I want you to have which compiles it. I want you to have a clean target, which gets rid of it, things that are not necessary. And I want you to have a run target, which actually runs the executable. That way I don't have to know what your executable is called. I can just type make run when I'm testing your program. Also, one other important thing. This is kind of a dumb little quirk, but underneath the target, you always have to have a tab. So everything has to be indented. Okay, if it's not, it won't work. So, for instance, let's get rid of that tab and then type make, and we get an error. So now we put in, whoops, I missed. We put in that tab, type make, and it works. However, if we put in this case, my text editor is being handy and telling me that I have to have a tab there. It's telling me spaces don't count as tabs. So, just so everyone knows, there is that annoying little gotcha. Okay, so any questions on that? How that works? Okay, so make is very powerful. This is just the simplest usage. You probably won't need to go beyond this in this class. So, now back to our slides. I'm actually going to skip this one and move on to this. So, I want you to submit a tar file. A tar file is not a zip file. So zip file is a form of compression. I'm not sure who it was invented by, but a tar file basically takes a whole bunch of files and puts them into one file. And then from there you can zip that file. And you zip it with this little Z flag. And so I'm going to give a short demonstration on this. So if we look here, we see my hello world directory, and we can type tar so the C, those are the flags. Tar is actually I think you can put a dash in front, it still accepts that. The C stands for create. So we want to create a new tarball, as they call it. They call it a tarball. I don't know why. The Z says, I want you to zip that tarball. And then F stands for file name. And so after the F, you put the file name of your zipped tarball. And then after that, you then list all the files that you want to do. In this case, we just do a single folder. And if we look here, we now have a hello world.tgz, which we can then upload to Canvas for me to look at. So then we also have to get these files back out. The X stands for extract. In fact, we're going to remove my hello world directory and redo that command. And you'll see it put it back for us. So extract, Z means it needs to be unzipped in this case, and F then is the file that you want to operate on. Okay? So that's that. And last but not least, I want to talk about version control systems. And this isn't required, but it could be really handy. Okay? So a version control system tracks changes that you have made to your files. It can also be used to facilitate collaboration between people. It allows you to go back in time, find bugs, see what's been changed. You can go back to previous versions of your code. You can look at someone else's version of the code if you're working together. And there's lots of different version control systems. So kind of the big ancient ones are called CVS and Subversion. You'll see those used in companies a lot. Kind of the new players are Git and Mercurial. Personally, I suggest using either Git or Mercurial. They're extremely helpful, extremely handy. I've listed here some books and tutorials on how to use these different ones. I use Git, not because it's better in any way, it's because it's what I learned. A lot of Mercurial is kind of the answer to Git. That's kind of what they deem it. It's the answer to Git. But Git is also the most widely used version control system out there. If you go to, for those of you working with Doug Hunsaker, you're probably familiar already with GitHub. Oh, bother. Which one is it? Let's try USU. See what that pulls up. Nope. I don't remember what it's called. Anybody? Oh, well. What we can look up, though, is my GitHub account. Oh, please. There it is. Ta-da! So I have a GitHub account here. GitHub uses Git exclusively for sharing code. This is a project that I worked on for my research. It's actually a C++ library for arrays that act like Fortran arrays. And it's a nice little thing. I can use this now as a demonstration of my programming abilities and stuff like that. And I can share with people. I've had some people download this from here. It's kind of nice. But I'm going to give you a brief demonstration of how this works. So let's say I have a project. Here's my project. The very first thing you're going to want to do is make a getignore file. Okay, and in it, you're going to list all the files that Git should never think about, okay? It's not going to track changes to those files. And I'm going to start, I always start off by saying ignore everything. And then I list the file types that I do want it to keep track of. So I wanted to keep track of .cpp files, maybe .h files. I want it to keep track of the make file. And I want it to keep track of the .getignore file as well. That should be part of your version control as well. So we make that file. And then I'm going to type get init. And what this does is it initializes an empty Git repository. And if we do a -a, you'll see we now have a .get folder, and that's where Git stores all of its information on your changes and whatnot. Don't ever touch it, okay? You're not supposed to touch that. And so now that we have that in there, now we can type get status, okay? And it'll tell us you have untracked files. I have not started tracking these files yet. .getignore, hello world, make file. Yes.
So since you initialized your Git repository in this folder, so for other people to access it, they have to access your machine, correct?
That is correct.
Okay, but you can do it, obviously you can do it other places, but just in this
Yeah,
case,
and I'm not going to be talking about sharing
right,
today.
Okay, sorry.
This is just for everyone's personal benefit. If you want to learn how to do that, you can come talk to me later.
Okay.
So it says, I have not yet started tracking these files. And so in order to track them, you have to type get add, and you list the files you want. Now, get add is recursive by default, so you can say add everything in this folder, as I'm doing here, or I could do, a file, just one file at a time. Okay, I'm just going to add everything. If you type a get status now, okay, now it's saying that, okay, you want me to track these files, but I have not yet committed to tracking these files. Okay, this is kind of the precursor before you tell Git the final answer. And so we can type, if we type get commit, oh, it's going to complain at us. Git loves to know who you are. So it's telling you you need to type this into your terminal here. And it's kind of ridiculous, but it likes to know who people are. So we're going to tell it who we are. There we go. How do you spell emeralds? Emerald. There we go. Okay, so now it knows my email address, and that's more for collaboration or sharing with people. That's what that information is used for. But we can now commit. It's going to open up the default text editor, which in this case is Nano. I hate Nano, but we then type some sort of information about what we are adding, what's changed in our source code. And so in this case, I'm just going to say, this is the initial commit. And we save it, and we say enter, okay. So now there is a separate program which is really handy, and I do not have it installed, so we're going to install it. So this is a GUI application. I know, I'm the terminal guy and I'm using a GUI application, but GUIs are useful in some circumstances. So what this does is it gives us a view of all the changes we have ever made. In this case, we have made one change, which is the initial commit. And it tells us down here, we've got the get ignore file. It says is all the plus signs here, meaning we've added lines here. And so it lists the 3 files that we've added. So, whoops, that was complete wrong. Okay. So if we type a get status now all it tells us there's nothing to commit. Nothing has changed. So let's make a change now to our hello world. How about this? Okay, well that's not going to compile, but that will. Okay, so we're going to make a change. Now if we type get status, it's going to tell us, hey, you told me to track changes to this one file, this hello world file, and you made a change, okay? So we can tell get, all right, I want you to keep track of this change. And we type get commit with a -m flag, and then we can add a message. That's what the M stands for. Okay, that prevents Nano from opening up because I hate Nano. Anyway, and now if we take a look at it, you'll see we now have an added extra hello here, but we also have the initial commit. Okay? And this is really handy. If you want, you can create a tag. And now we have a little tag called initial on that first commit. So let's say maybe we didn't like that change, or maybe we need to go back and look at something. If you use the checkout command and that tag name that we just put on there, okay, it's going to complain about some stuff. I wouldn't worry too much about that. But the beauty of this is my extra hello world is gone. Get has taken my file back to the way it was. Okay? And that is the most handy part about this, I've found, in using this. And Get has saved my bacon on many, many occasions. And if you're going to look up Mercurial, it's very similar. They kind of do the same. All version control systems do the same thing, just in slightly different ways. And if we want to go back to where we were, we check out the master branch, which is the default branch that Get sets up for us. I wouldn't worry too much about that. But that takes us back, and if we look up hello world, we'll see it's now back. We've added in that change. And Get keeps track of all of that, so it's really handy. And of course, there is a ton more to learn about Get, but that much should at least get you going if you want to use it. All right, we're out of time, but I wanted to this class period because we really have to get moving on the actual fun stuff. Since we're going to be forced to use Vim, I wanted to do a primer on Vim. Is anybody going to object to that? If we take 10 or 20 minutes to do that? Okay. And you people watching, I'm sorry, you'll just have to watch longer. So, in Vim. Vim is a text editor. It's based on an old text editor called VI. VI was invented when screens were all green, when they were, 80 characters wide, and when you didn't have a mouse, you didn't have arrow keys, you didn't have number pads. Okay, so that's kind of where a lot of this stuff comes from. But Vim stands for VI improved, as it says here on the opening screen. They've taken VI and made it really cool. So let's open up, let's go back to my Hello World. Okay, so I've now opened up this file in Vim. Now Vim is nice. It is syntax highlighting this for me because it recognizes the .cpp extension as meaning there should be C++ code inside of here. You'll notice I have numbers on the left. You may or may not have numbers. I'll get to that in a bit. But the important thing to note is right now we are in normal mode. Okay, so this text editor is based on modes, and there's 5 different modes, I think. And I've posted a really nice PDF tutorial on Canvas that I found. It's called A Byte of Vim. That's where I initially learned from. So hopefully if you read through that, you can feel more comfortable with it. Anyway, so right now we are in normal mode. And you'll notice if I try and type stuff, well, okay, that actually did something. Not what I was expecting. If you try and do something, oh, now it types. It's not going to work the way you think it should. Because the normal mode is where you execute commands and things. If you actually want to type, you have to push the letter I. I wish I could have a keyboard on the screen here so you guys could see this. But if you type the letter I, you'll notice down in the lower left-hand corner, it now says insert. And this is one of those improvements. VI itself does not tell you what mode you're in, which is annoying. But Vim will tell you what mode you're in. We are now in insert mode, and we can type stuff. Okay? Oh, and I just screwed up there. So that is how you actually type stuff. In order to change modes, the escape key will always take you back to normal mode. And I'm really lazy. I found it was really hard to move my hand to escape, so I actually made my caps lock key be escape. Which screws me up on everyone else's computers, but my caps lock key is now escape. And escape is now caps lock, so... anyway, so the escape key will take you back to normal mode no matter what mode you're in. And there is also a visual mode. If you type the letter V, you get a visual mode. As long as caps lock isn't on, that's better. Okay, and you'll see it allows me now to select stuff. Okay, again, escape, and I switch that. Escape takes you out of visual mode. Also, since this comes from an era in which there were no arrow keys on your keyboard, they had to figure out how do you move around. And what they came up with was HJKL. Okay, L will move you to the left. H moves you to the right, or I got that backwards. J takes you down, and K moves you up. Okay, it's a little weird. You can use the arrow keys in Vim. You can't in VI, but in Vim you can. So you don't have to worry about that too much, but if you're ever confused, that's what's going on. Now, then let's see, if you want to save, you want to type colon. Now the colon opens up the command line, if you want to call it that. You'll notice down in the lower left-hand corner, we can now type stuff. If you want to save your changes, you type a lowercase w, which stands for write. Okay, and now it tells me, hey, I've written hello world.cpp. If you want to quit, do a colon Q, quits. You can actually combine the two. You can write and quit, which is really handy. And if so that, I mean, if you know that much, you can get around Vim, but there is so much more to it than that. In normal mode, you can do things like delete entire lines. Say I wanted to delete everything up to the semicolon. You can do that. You'll see I'm left with a semicolon now. If you want to undo something, you have to be in normal mode, okay? And then you push the U button for undo. You'll see it undoes each change one at a time. So, so copying and pasting. This is another big thing. So I find the easiest way to copy and paste things is using visual mode. So you select what you want to copy and you type Y. Y stands for yank. Now it's important to realize if you're working in the terminal, yanking does not yank to the system clipboard. Okay, it's not like Windows. Okay, it's actually yanking to an internal clipboard that is internal to just this window. Okay, Vim maintains 26 different clipboards, one for each letter of the alphabet. Okay, and there's a default one that you can use. So Y yanks, and then P stands for paste, and it pastes from that internal clipboard. There are ways to get the system clipboard, but I'm not going to worry about that too much. So D stands for delete. So if you go into visual mode and select what you want to delete and push D, it'll delete it. Okay. What else? Any questions from people on?
One thing I figured out the other day that was causing me confusion is that delete puts it to the clipboard as well.
Yeah, it does.
Yes, yes, that is right. So
Trying to like copy and
it's actually
delete
cutting
and then
it.
paste.
yes, so the delete, the internal Vim clipboard, that's right. When you delete something, it's actually a cut, and so you can repaste it. So thank you. Another shortcut, if you want to delete an entire line, you just push D twice. In fact, most commands, if you just push it twice, it will operate on the entire line. And like he said, it takes that and puts it in the internal clipboard, and so then we can repaste it using P. So let's undo that. And then, what else? Okay, so that's kind of the basics for that. Now, in your home directory, you may or may not have a vimrc file. Okay. Now, this is where you can keep all your Vim settings. Now, this is mine, and you'll see it's really big and it has a lot of stuff in it, because I've been at this for a while. But here's some useful ones here. Syntax on. Okay, and that one turns on syntax highlighting. Set number gives you numbers on the left side. Set mouse equal A. That one's really handy because it lets you use the mouse. Then there's a couple others. Set auto indent will actually, based on the C or C++ file, will actually indent when you push enter and say, oh, you have an open bracket here, so Yeah, that one's really handy. Yeah, there we go. Here's some tabbing options. You can set the width of your tabs. I'm not sure exactly what all those do, but I found it in the help documents. There's lots of information online on how to work with this. If you're working with Fortran, these ones are really helpful. Also, just so you know, expand tab, what that will do is whenever you hit the tab button, instead of inserting a tab character, it will actually insert spaces in its stead. And I personally like that. Some people
There's a
don't.
problem when you're making make files, though.
However, Vim is smart. It knows when you're in a make file.
Are you sure?
Yeah.
Because I swear I've tried it and it has given me problems before, but maybe not.
Maybe we should look that up. So here's another thing. If you type :H, that stands for help. Let's see if this pulls anything up. Nope. Okay. Let's type H expand tab. And it pulls up a handy dandy window on how to use expand tab. It is off by default. It is local to the buffer. Don't need to worry about that. Okay, so it says, in insert mode, use the appropriate number of spaces to insert a tab. Spaces are used in indents and when auto indent is on. To insert a real tab, you can get around it by typing Control V and then your tab. So that doesn't tell us anything about like programming languages like Make or Python where you have to use tabs. Doesn't say anything about that. But I do know there are ways around it. So,
Okay.
and it actually may come in here. This file type plugin indent on may take care of that. I'm not sure. Typically, you will need this set no compatible line up top if you want to do anything fancy.
What does that do? The set no compatible?
I don't really know. I just put a comment there that says it's required. So I haven't touched it since, and I don't really remember why it's up there. But okay, so if you want to copy and paste from the system clipboard, this is what you'll need. And what that does, it just says if you type the leader, which is typically the /, so that's leader right there, followed by a V or P or C, depending on whether you're in normal mode or visual mode. We'll paste from the clipboard or yank to the clipboard, the system clipboard. Okay, so one other thing that's really handy is searching. So if you want to search, you want to type these !/. Okay, you'll see in the lower left-hand corner, I now have a slash there. And from there, I can search for the word plugin, and you hit enter, and it jumps to the next word, the very first match that it finds. And then if you hit N for next, it'll jump to the next one. And so in this way, you can search through your text file and find everything you want. If you want to go back, you do a capital N. It goes up instead of down. Okay, so that's pretty handy. Is the searching. It says I've changed stuff, which I did. So if I want to quit, you see it's not letting me quit, so you have to add an exclamation point. Vim tries very hard to make sure you don't lose your information. It says you can't quit because you've changed stuff. So you add an exclamation point after the Q, and it lets you quit. Okay. So if you want to learn more, there's lots of stuff online. I'm willing to answer questions, but that should get you started at least. Any more questions on that? Oh, here's another thing. If you type Vim tutor, okay, it actually opens up a tutorial file that you can read through. And so you can get more comfortable with using Vim. And if you ever see me do something that you think is really cool, go ahead and stop me and ask me how I did that. And I can explain it. So, anyway, so that's the end of today's lecture. So tomorrow we will actually get started on the fun stuff. So I hope more people show up. One day there's not going to be anyone here and I'm going to be talking to an empty room. So that's what I get for recording things, huh?